welcome to the Talking Crop podcast. My name is Kathryn Seebruck, and I'm a commercial agriculture educator with University of Illinois Extension serving Daviess-Stephenson and Winnebago counties. Talking Crop is a row crop production podcast with episodes occurring every other week during the growing season between May and September. In each episode, I bring on a guest speaker to discuss topics related to their areas of expertise. In today's episode, I am joined by Trent Ford, the Illinois State Climatologist with the Illinois State Water Survey. We discuss severe weather in Illinois both this season and beyond, El Nino, and the big three climate trends in Illinois and their effects on agriculture. In the episode description, you'll find links to the State Climate Office website, which holds useful data such as precipitation maps, soil moisture, and more, as well as a link to the CocoRaHS network where you can view the CocoRaHS map and learn more about joining. For the next episode of Talking Crop, I'll be joined by Madeline Solovsky, Michigan State University Extension Conservation Agronomist Educator. We'll be discussing cover crop planning and decision-making, including mixtures, varieties, interseeding, and more. That episode will air on Wednesday, July 22nd. And now, please enjoy this episode of Talking Crop, Climate Trends in Illinois with Trent Ford. Hello, Trent, and welcome to the Talking Crop podcast. Thank you for being here today.
Hey, Kathryn. Thanks for letting me join.
So I am going to have you kick things off with a very easy question. If you could please just first introduce yourself to the audience, so a little bit of your background and what your position is and what you do in your position.
Yeah, so I'm Trent Ford. I'm the state climatologist for Illinois, and I've been in that role for almost 7 years now. I took over for Jim Angel, who was state climatologist for quite a while. My background is, so I was born and raised my entire childhood in central Illinois, in a small town called Roanoke, not too far from Peoria. I studied at ISU in Illinois State, did geography there before moving to Texas A&M to do graduate work, did master's and PhD in climate science. That was kind of my background. And then before I took this position at the U of I was a professor in geography at SIU in Carbondale. So I moved back to Illinois and have sort of slowly migrated back to central Illinois where I sit today, and I'm not going to leave. My job is kind of a mixed bag. It is part research, so I'm a researcher by training. I do a lot of work especially related to water extremes, including flooding and drought especially. But as state climatologist, it's sort of a unique role where I also do a lot of public engagement, outreach, sort of applied work. And that can be everything from working with state agencies for planning purposes, all the way to local forms of government, private sector and industries here in the state, and then a lot of public engagement work. So public speaking, media work, that sort of thing. And all of those really touch on various aspects of weather and climate. And so everything from what happened yesterday and why did it happen to what's going to happen over the next 30 years, things like that. So I kind of act as the point person on weather and climate for the state.
And so with that, I'm sure that you were very busy or have been very busy this past spring or this current spring with all of the very crazy extreme weather experiences that Illinois basically undertook throughout between like April and even up to this past week or so, I believe.
Yeah, it has been insane. And so, I mean, we can characterize it by numbers, I suppose, but I think more importantly is that we have seen just probably what is the most intense severe weather year, perhaps in record, certainly in recent memory across the state. All the way from March, where we saw potentially record-breaking hail in Kankakee that's still being reviewed, all the way to just here in mid-June, where we had something like a few dozen tornadoes over the past week or so in mid-June, including a handful of EF3 very large tornadoes here in central Illinois. So yeah, it has been incredibly busy. I think this week, the week of June 21st, I think I've done about 20 interviews, just for media, just same thing, like, why are we getting so many tornadoes? Where are we at? What's causing this? Is this the new normal? Are we all going to die? Things like that. It's been insane. And just to kind of put it in like quantitative terms here, on June 25th, the National Weather Service has confirmed we've had 173 tornadoes in 2026 in Illinois. That breaks our previous record in 2024 of 142 tornadoes, so breaks by 30, which is, just smashing it. Mm-hmm. And to give you an idea, over the last 30 years or so, we've averaged about 50 to 60 tornadoes per year in Illinois. So it's just outrageous in many ways.
So not to make you repeat your answer to a very commonly asked question, but what is the reason that we have gotten this crazy outbreak of tornadoes? Or is there an easy reason to even give for that?
There's an easy reason this year, especially in June and maybe in April. So what we've seen over the last 4 years is not just like a tornado every day. I mean, you can divide it up and say, okay, we've had 180 some odd days in 2026 so far, and had 173 tornadoes. That's a tornado almost every day, but it doesn't really work that way. In reality, we have these big tornado outbreaks where there's nothing, and then here's 24 tornadoes in a single night. So we had that in April and then again in June this year. And in both situations, in really all situations with tornadoes, you need a handful of ingredients. You need the instability, which is usually forced by heat, humidity in the lower level of the atmosphere. That's the situation where, as Midwesterners, we come out in the morning and just kind of smell it in the air, like, oh, this is going to be a bad day with tornadoes. We also need the upper level of the atmosphere to play ball with its wind shear, which means like a change in wind with height and speed. And so when we get those two ingredients in some form, we tend to have more efficient storms as far as putting down tornadoes. In April, we tend to have a lot of shear. The jet stream is very active, that sort of thing. Not as much instability because it's still April. It's not super hot. In June and July, we tend to have the opposite. We tend to have less shear, but a lot of instability. And in fact, this year it's been flipped. So April was actually quite warm. It was the warmest April on record statewide. So we had a lot of instability. And when we had storms firing off, they were just popping tornadoes like crazy. In June, we had a big trough in the upper atmosphere over the Midwest, which is why kind of that middle part of June was actually quite a bit cooler before the heat came back in. And that combined with flow out of the Gulf of Mexico at the lower levels provided the wind shear to give us the many, many tornadoes that we had in the month of June. So this year has been incredibly active because of the right combination of ingredients that in some cases is unseasonable. However, if you ask the question, okay, that explains 2026, but what about 23, 24, 25? And why we've had 4 years in a row? We don't have a good answer for that. Likely what's happening is we see some sort of larger pattern that's making for the right weather situation to create tornadoes, and it's just persisting or appearing more often over the last 4 years. But we really haven't put our fingerprint on exactly what that is and why we saw that flip from 2022, where we had 37 tornadoes in Illinois, to 23 and beyond, where we've had over 100. So it's really fairly easy to explain a single year, single month. Over the last 4 years, it's a little bit harder, and something that we're hopefully going to be able to assess later on this year.
That's interesting. I guess it's kind of nice to have everything buttoned up for 1 year, but then you have that frustrating aspect of those other time frames trying to figure those out.
Yeah.
That's fascinating. And another weather phenomenon that is relevant right now, I believe, is El Nino, correct?
Yeah, we are in El Nino. Officially, we got into it in June. So what El Nino is a single phase of what we call the El Nino Southern Oscillation, or ENSO. The El Nino Southern Oscillation, so the idea of an oscillation is something going back and forth, back and forth. So on 3 to 5 year time periods, the El Nino Southern Oscillation just describes the kind of flip in temperature patterns in the tropical Pacific Ocean. So if we think about our geography, the tropical Pacific, especially south of the equator, running from off the coast of South America, Peru, Ecuador, all the way across the ocean to Australia, that water is moved from South America to Australia by the trade winds, that part of the country, or by part of the world. When the trade winds strengthen, that water is moved more quickly across the ocean, and it has less of a chance to warm. And so we tend to have cooler water across the Pacific in that area. And because that water is being moved so quickly, we get upwelling of cool water from the deeper layer of the ocean right around South America. So you get this pattern of anomalously cool water in the tropical Pacific. That's La Nina. And its opposite phase, we tend to oscillate back and forth, again, 3 to 5 year time periods, is El Nino, which is what we're in now. In that situation, the trade winds slacken, and so they don't blow as much as quickly. And so the water moves much more slowly as it moves across. It heats much more effectively. So we have an area of anomalously warm temperatures across that tropical Pacific. Now, why does this matter? Why do people pay attention to this? Is because the Pacific is massive. It's a huge energy sink. And where the patterns of cool and warm water are and how cool and warm they are drive where we get convection and storms in the Pacific, which modulates the jet stream. So, and we are affected by the jet stream, and we are, because air tends in the northern hemisphere to move west to east across the northern hemisphere, we are downstream of the Pacific. So what happens in the Pacific is very important for weather all across the United States. So that's what's happening right now. Now, what El Nino tends to do, and La Nina, is when it develops, oftentimes in the fall, sometimes like this year, it happens in the summertime, it tends to strengthen and reach peak intensity in our wintertime. And that means that we tend to see the effect of El Nino most in the fall and winter here in Illinois, in the Midwest, and across much of the U.S. It tends to weaken by the spring, that subsequent spring, and very rarely does it last through the summertime. And so that's what we're seeing. What we're seeing right now is the formation of El Nino. It's expected to carry through the fall and intensify into winter, and then we'll see what happens in spring and summer of 2027. What's really interesting about this pattern, this particular event, is that it is predicted to become a very strong El Nino. So well over 60% chance of becoming a very strong El Nino. Now, what is the difference between a strong and a weak El Nino? It's just how warm those surface waters are. So when we have a weak El Nino, the water is warmer than average, but it's not extremely so. When we have a very strong El Nino, like what we did in 98, 99, and then 2015-16 were the last two big ones. That creates a little bit. It can create a little bit of a stronger response in our weather. So that's where we're at now. I will say, since we've transitioned from tornadoes to recent tornadoes and recent severe weather to El Nino, I will say that, we're in El Nino, but again, because of how our weather works in here in Illinois, and because of El Nino's kind of strengthening, we tend to see its largest impact in the fall and the wintertime, especially, not so much in the summer. So nothing that's happened so far here in Illinois, the record-breaking tornadoes, the crazy hail, the whatever wind, none of that is directly due to El Nino.
So with El Nino being strong this year and its effects being most prevalent in the fall and the winter time, are there any general predictions that we can make about what the fall and winter might experience weather-wise?
Yeah, so we do see signals when we look at past El Nino events. Those signals tend to bring, for the Midwest, milder, warmer than average temperatures for fall and especially winter. We also tend to see a dry signal in late fall to early winter through the midwinter. And so what we've seen from previous El Nino years, when you put them all together, is, especially for the winter season, think about December through February, warmer and drier than average. That's typically what we see. Now, different El Nino events have given us different types of weather. So it's not a guarantee, right? It's just one very important driver of our weather, but not the only driver of our weather here in Illinois, even there in the wintertime. But when we put them all together, that's kind of the tendency that we see. A little bit milder temperatures, especially the wintertime, and a drier signal here in the Midwest.
Sure. Well, my huskies have turned me into a snow person. So if we don't get snow, I'm going to be very sad.
Yeah, and I know, and when we kind of layer on top of that these long-term trends and reduced snowfall, it doesn't paint a very good picture of a very healthy snow. However, we've seen El Nino years with a lot of snow, so we'll see. But yeah, it's I wouldn't necessarily. This is not necessarily the winter season to go invest in a snowmobile.
Right.
Yeah.
And you mentioning the lessening snowfall, I'm glad you brought that up because I was going to ask. I feel as though we don't really get white Christmases anymore. And I didn't know if that was, my childhood rose-colored glasses being put on, making me think that we used to get those.
Yeah.
So is that the case then, that we are trending towards like less snowfall in the winter over time?
We are trending to less snowfall a little bit across Illinois. The idea of the white Christmas, there's two things at play there real quick. One is that it's sort of a random, when you say like, what's the likelihood of getting snow ahead of or on a specific day, like Christmas Day?
Right.
It's like year to year, it's so variable that we really can't track trends. But what we do see when we look at the entire winter is reduced snowfall, and especially less snowfall early in the season. So when we break it down by month over the last 50, 70 years or so, we see not much change in snowfall, especially in northern Illinois in January and February, but less in November and December. So that first snow of the year may come closer to after Thanksgiving as opposed to before. What we're also seeing is that we tend not to hang on to snowpack as long, which is a big trend that also kind of has implications for recreation, snow recreation, as well as, like you mentioned, like even holidays having white Christmas. So very rarely now in central Illinois especially will we get a snowpack, and it will last for more than just a few days. We actually had one this last winter here in the Champaign area where we got 6-7 inches of snow, enough to sled on. And it stuck around because we had prolonged cold for like 5 or 6 days. And it was actually kind of odd to be able to sled in one weekend, and then the snow was around for the next weekend too. It's just something we don't see as much anymore. And growing up near the Peoria area, rose-colored glasses bias of my childhood, I do remember being able to see that snowpack stick around a lot more than we are these types of days. So we see those trends there. But it is important to understand, this El Nino conversation is a good example of how year to year, decade to decade weather variability can play up on those trends. So we have this decreasing trend in snowfall, but we can get a big La Nina year and it actually makes for more than average snowfall, or the El Nino year can actually exacerbate that decreasing trend. So that's how the climate and weather kind of work together to make for interesting patterns in a given year.
So switching gears a little bit more towards some bigger general questions as it pertains, or as they pertain to weather and climate. Looking specifically at Illinois, what are some of the biggest climate trends that you're seeing in Illinois right now, or, obviously with weather, it's over time, right? So right now, as it pertains to the past, and you could put whatever range of years you want on that, what are some trends that you're noticing?
Yeah, I call it the big three, which is like the easiest way to summarize these kind of longer term climate trends in Illinois. And we say in Illinois, if anybody's listening from Wisconsin or Iowa or Indiana, there's everything's special about Illinois, but it's the same in those states as well. The big three are heat, flooding, and changing seasons. So breaking those down, what we've seen over the last 100 years or so is an increase in the frequency and intensity of extreme heat, particularly very humid heat conditions. So sometimes I'll hear folks, I heard it this morning on a radio station that shall not be named in the Champaign area, that we're getting more 100-degree days in Illinois. That's not true. It's true nationwide, but it's not true in Illinois. That's an idea of applying a nationwide trend to a local place. It's not the case. Instead, what we're seeing is a lot more humid heat conditions. So we're not getting above 100 degrees more often. What we're doing is we're staying in the 90s more often and having dew point temperatures well above 70, which means that our nighttime temperatures are staying above 70, in some cases above the 80s for more days during the summertime. And so that combination of heat, but the humidity especially, and the string of very warm nights puts a lot more additional stress on crops, on animals, and on humans. And in fact, a lot of studies have found that those nighttime temperatures are actually more important or more predictive of impact both to crops and to people and animals than those daytime high temperatures are. So it's a combination of the heat and the humidity that we're seeing that trend. The flooding is the flooding trend is an increasing trend. It's something that probably is not surprising to people because it's a little bit easier to see, especially with heavy rainfall. So the idea is that Illinois has gotten wetter over the last 100 years, but it's not all that important. What's really important is that we see that rainfall in larger doses with fewer or longer stretches in between. And so what we get is very heavy, intense rainfall, which increases runoff and stream flow and inundations. So those are things, these very large rainfall events. Just a few weeks ago, while taping this, we had Danville getting nailed with like 6 inches in 6 hours. And these are the kinds of events. And certainly, I mean, the Rockford area is no stranger to those types of events. Those things are, we've seen them become more frequent, more intense. And so the issue with the really heavy rainfall type of flooding, it differs from the river flooding because for river flooding, we kind of have that well studied, well understood, well mapped. So we know when, let's say, the Rock River is going to flood. Well, the Rock River is in a perpetual state of flooding, seemingly, but when it floods, we know how extensive that can be and roughly how often that happens. Also, when the Rock River is going to flood, in general, we get a pretty good warning because usually it means there's been heavy rain or persistently wet conditions upstream in Wisconsin that's going to be moving down. So we can get a couple of days, if not a week heads up. People can sandbag, move things out of the way. It's okay. The problem that we really see more often and more pernicious is this really heavy rainfall that just inundates. And that means that we get flooding and inundation outside of map floodplains in places where people, A, don't have the maybe the resilience or the adaptation, the protections from the flooding, but also we get less warning. Right? Like I mentioned that event in Danville the other day, it was basically just a run-of-the-mill thunderstorm that was just set up in the right way to produce a really heavy rainfall amount. So by the time the National Weather Service was like, whoa, this is a problem, we had already gotten several inches of rain and there had already been flooding. So really, we don't get that warning with those types of events. Those things are increasing. So that's number 2. Number 3 is the changing seasons. We just talked about this with the snowfall. One thing is that like every season in Illinois has gotten warmer over the last 100 years, but winter has warmed at a much faster rate, which changes the seasons. And so what we've seen is that winter temperatures, especially those extreme cold temperatures in winter, becoming less and less frequent means that we can get a change in ecosystems, in the makeup of how ecosystems are functioning, what species are part of those ecosystems, as well as for agriculture, the timing and the phenology. So if we're working with perennial plants, when those plants are breaking dormancy, when they're setting flowers, when they're becoming mature, and for annual crops, when that growing season is occurring. And so all of those things are kind of combining to make for a really complicated outlook when it comes to agriculture in particular. Because it's not just that, okay, we got to deal with more heat. Yeah, okay, we got to deal with more heavy rain. That's a challenge as well. But now all this as well, the change in winter also means that the same types of insect pests or weeds or fungal disease pressures are hitting perhaps more frequently, but also changing in their timing. So it changes scouting, it changes strategy. So all of those things are kind of in a combination are ways that we're seeing the changes in weather in Illinois that can be impacted by agriculture. And there's a lot more detail. I know I just spent like 10 minutes on that, but there's a lot more detail we can get into, obviously. But those are like when I like to summarize kind of the big 3 that have, I think, the biggest impact on ag.
And with that, I know obviously all 3 of those have some, I would say mostly negative implications when it comes to agriculture. And, we're on a row crop agriculture podcast right now. So of those 3, are any of them in particular, do they stand out to you the most as being maybe the most concerning or something, the most that maybe a producer should try to pay the most attention to and maybe adapt certain things to become more resilient to those events?
Yeah, for agriculture, it's I would say the change in seasons has brought the benefit of longer growing seasons. So folks are able to expand the northward, the areas that you can consider double crop beans. And not only is just like that double crop bean, it's not a throwaway crop anymore. It can actually yield almost as well as single crop beans are. So I'm seeing a lot more wheat production here in Champaign area in central Illinois, but also I've seen that in northern Illinois start to expand as well. That's in no small part due to the obviously the hybridization, the genetics of the wheats, but also that warming temperature. So there can actually be a benefit to that, certainly. As far as the biggest negative impact of the thing to look out for farmers, and this should be a surprise to nobody, is the precipitation variability. I'll just call it that, where we're swinging from extremely wet to very dry in sort of these unpredictable patterns. So, in some ways, our trends in precipitation have been beneficial relative to other parts of the country. Like if you're farming in Arizona, if you have an alfalfa farm in southwest Utah, there's real questions if you can actually maintain your livelihood in the next 10 years or so. Like, should you grow alfalfa in southwest Utah? That's a major question because of water restrictions there. We don't have that in Illinois. And when we look forward the next 10, 20 years, we're not going to see, there's a lot made up of, the corn belt is moving, to the northwest, that sort of thing. It's like, yeah, call me when Illinois is not leading in corn yields in the country, right? We'll be able to grow corn here for as long as we can. The issue will be is the precipitation variability is really challenging because it's not like I mentioned the desert Southwest where it's just getting drier and drier and drier and drier. We see a little bit of a wetter trend, but it doesn't really matter. The big thing is the variability. So farmers have to really be thinking about how you're going to manage that water, but on both sides. Because if you just say, well, we'll put in tile, which has been the largest adaptation strategy, arguably, for farmers in Illinois over the last 20 years or so, if that tile is uncontrolled, what you're doing is you're dropping your water table level great when it's in May, but when it's in July, that's a problem. Especially when we go these periods of time when it's warmer in the summertime, so you're evaporating more, you're losing more of that water, but at the same time, you're dropping your water table level. So, and that, by the way, that more intense rainfall is increasing runoff, which means you're getting less effective recharge into the soil. So you got to really hang on to as much water as possible. So I think this is the one of the challenges that farmers will continue to face in Illinois in the foreseeable future is how to manage not just too much water or not enough water, but kind of swings between those states. And again, there's lots of ways to do that. Some are better than others. Some work better in certain situations, better than others. But this is something that in general, I guess from my perspective, what I would say is for producers in Illinois, that what we've seen over the last 30, 40, 50 years with more variable precipitation, wetter wets, maybe prolonged periods of dryness, that's something that our models project will likely continue into the future, if not intensify. So it's something that folks really should plan for if they haven't already.
Yeah, and understanding that, I think naturally the next question becomes, so what do we do about it as producers? How do we adapt to that? And our conversation today is very timely because yesterday I was just at actually a land improvement contractors association workshop where they talked about, of course, drainage a lot and these drainage systems that are very that you can manage. So you can kind of manage the water in, below your field. When it's, really wet, let it drain. When it's really dry, retain that. And that can be really helpful for those times in which the weather variability can be extreme. And, I sit back, I work with farmers directly, and it's hard for me to think that they might see those things as being a worthwhile investment, especially on every single one of their fields, right? But talking about these weather extremes, it does push me a little bit more towards that middle area of, well, if this is the general trend, and if the trend continues to worsen or intensify, then maybe it is more worthwhile than I or a producer might think.
Yes. I mean, it really boils down. It always boils down to economics. In some ways. So, this, obviously I'm just preaching to the choir, but producers, some feel a strong tie to conservation, more than others. And maybe those folks will be more strongly motivated by kind of a conservation, environmental health type of strategy, where maybe the economics or profits could be sacrificed slightly for a little bit more conservation. But that message has largely not motivated like large scale action in recent decades. So it's really the profitability. And so one of the things that I've taken away, so obviously every year I do these, I'm on the Dog and Pony Show for Extension and others. We're going around, right? There's somebody around the state, sometimes into Iowa, they let me in there, and I'll give the weather briefing. There's an economics briefing, and then there's a pest briefing, everything else, right? And I know you've been part of these many times. This is the first year where I've really heard a lot of the ag economists in the state, and not just here in Illinois, but honestly, really sit down and almost like a fireside chat with producers and be like, look, this is a bad time for farmers, given crop prices, input prices, everything. You need to be thinking profit, right? Not yield. You need to think profit. And so I think that who knows what crop prices do with the emergence of South America as, and with inputs and geopolitics. I mean, this is I certainly can't predict it. I think the weather is more predictable in some ways somehow. But what that means is that as this relates to dealing with water challenges, we have to be looking at profitability and not just necessarily maximizing yield. So there are situations and systems where managed drainage is the best call. Maybe not the perfect. There's no perfect solution, but maybe the best call in the situations to maximize profitability. There may be some situations where farmers need to be thinking about maybe taking certain acreage out of production just because it's simply not worth the input costs. I see there's a field between my house and Bloomington Normal. I won't say where, just in case somebody's listening. Every single year, except the worst drought years, there is inundation in that field, and there is very poor, if any, emergence. Or if the flooding comes later in the summer, it's just a dead crop. It makes up probably together across this field maybe 1.5 acres to 2 acres. Unless that farmer is not putting input, which I seriously doubt into that, those are acreage that probably is not worth farming. And there's some of that in a lot of fields. So just understanding where that comes from. So that's a management strategy. Changing cropping rotations to reduce the inputs, but also be able to maybe reduce some of the soil erosion that comes with heavy rainfall. People are seeing those problems. That's another issue. Thinking about nutrient management and how best to keep the really, really valuable, costly inputs, especially with nitrogen, on the field. Obviously, we talk about the environmental concerns that come with nitrogen leaving fields into the water systems, but that's money leaving. I mean, you might as well just throw the money down the ditch as well. So there's a lot of different ways to manage water. Some are more costly than others. Some are more efficient or maybe more effective than others. And there are lots of solutions out there that may or may not fit a certain practice. So it's just another call when, and I've been trying to change my wording of my talks to fit more with the economist way of saying, like, look, we have to, whatever you're doing, here's a problem. It's an increasing problem. It's going to continue. Think about overall profitability on the farm and try to lay out the best practices that work for a specific situation.
Sure. Yeah. And I think that conservation point that you were making is really important too, because, we see with these more conservation practices like reduced or no-till, cover crops, those types of things can really improve soil health. And as a result, your fields become inherently more resilient. They can withstand those intense rainfalls a little bit better, and you'll get less inundation because you have better water infiltration, things of that nature. But I also understand making that jump towards those practices. That's an economics thing, right? It's risky and it can cost money or potentially lose you money in the first couple of years. So it's maybe not a wicked problem, but it's a complicated problem, but something that certainly to think about.
Yeah, I'd say it's a wicked problem, right? I mean, there's no perfect solution. Every solution has trade-offs. And you mentioned economics is a social, right, too. I mean,
yes.
Doing something for decades in a certain way, and then, nobody wants to change something. And so, in some ways, it really takes that external factor. Maybe it's the really terrible crop prices lately. Maybe it's the increasing input costs, or the combination, the recognition, the federal programs and incentives that may be available for some of these conservation strategies. I mean, all these things can provide that push to kind of try these out. But yeah, it is it is important to acknowledge that these strategies and managing this problem is necessary to ensure economic sustainability of any farm system, but that none of these solutions are going to be perfect. So if farmers are out there and saying, I'm only going to implement the perfect solution, then you're not going to do anything, because there is no perfect solution. That there are trade-offs, but those things can be managed in such a way to make it an overall benefit to the farm.
Moving away from this, I wanted to let you talk about some of the projects that you are currently working on. You sent a couple of them over to me, and the first one is the Illinois Mesonet. So could you describe what that is and what your goal is with that?
Yeah, so a mesonet describes a relatively dense network of weather stations across what we call like a mesoscale area, which is, think about like county to statewide. So across the country, the National Weather Service manages a lot of weather stations, hundreds and hundreds. They range from volunteers taking daily measurements of temperature precipitation to, at airports especially, doing the hourly measurements of temperature, rain, wind, things like that. But together, it's still a fairly sparse measurement system of weather. So there's a lot of holes. What mesonets have really come in over the last 40 years or so across certain states, the states have built up their own more dense network of stations to capture those types of weather conditions that get missed by National Weather Service. And so the mesonet, the purpose of a mesonet is to better, more densely, and more effectively monitor the weather to improve monitoring aspect and our understanding of the weather, but also prediction. Because our forecast models, our weather forecast models, are only as good as the data that we feed into them. And just take like, the kind of north central Illinois as an example. If we are generating hourly weather forecasts from a weather forecast model, which is something that the National Weather Service is doing, and we have to feed in hourly observations, in that area, we may only have, 3-4 stations that we're actually measuring weather. We're measuring in Rockford, we're measuring in DeKalb. There may be one in Freeport where it's measuring hourly, right? So we're feeding that in, and that's great, but we know that, especially with precipitation, with extreme weather, things like that, there's a big difference sometimes between what Rockford experiences, what DeKalb experiences, what Freeport experiences. So filling in those gaps is critical for not only better monitoring the weather, but also forecasting and understanding what's happening. So many states have been historically ahead of us here in Illinois. Oklahoma is sort of the gold standard. We have developed a mesonet, so to speak. It's called the Illinois Climate Network. It was developed in the 80s. It's got now 20 stations across the state of Illinois, which is great. And it takes 5-minute observations of temperature, precipitation, wind, pressure, soil moisture. It's really the only consistent source of soil moisture in the state. And 20 stations is wonderful. But to give you an idea, Oklahoma has 120 stations, and Kentucky has 120 stations and growing. Wisconsin has 80 stations. We can't let them beat us. So the reason that this matters is, again, that density. We think about a derecho moving through an area. Let's say it's coming from Iowa, because we get all of our derechos are locally sourced from Iowa, unfortunately. So it's moving northwest to southeast, and we get one wind measurement from Freeport, right? You're sitting in Rockford, or you're sitting in DeKalb or Sycamore, and you're like, okay, how bad is this? You get one measurement from Freeport saying it's 70 mile per hour. But with the derecho, we know that there's pockets of much stronger winds around weaker winds. So there could be a pocket of a 90 to 100 mile per hour wind just south of that we don't measure, because we don't have that dense network. And all of a sudden that moves through another area and we have big problems. We saw that with the 2020 August derecho that moved through Iowa. So what we're proposing here is to build out the Illinois Mesonet from 20 stations to 100 stations, almost one per county, over the next 5 to 6 years. That provides us the density of measurements that we need to better understand and forecast extremes like derechos, heavy precipitation events, dust storms, things like that, all of those types of extremes that unfortunately we're experiencing here in Illinois. At the same time, very exciting, we are also proposing to, in a handful of stations, include automated drone sensing of the atmosphere from not just the surface, but up to 10,000 feet or so. So the National Weather Service keeps those surface weather stations, but they also launch weather balloons to get the upper atmosphere conditions, because it's really important, not just what's going on at the surface, but also in the upper atmosphere that dictates what we experience as our weather here. It may come as a surprise to some, but the National Weather Service only regularly launches weather balloons from one place in Illinois, and that's down in Lincoln, which is in the Central Illinois Weather Office. The Chicago office, the Davenport office, the Paducah office, the St. Louis office, the Indy office, they don't launch weather balloons. One part in Illinois, which is obviously not nearly dense enough to really get a good idea of what the upper atmosphere is doing. So what we're proposing is on a handful of stations, ideally maybe 10 stations or so around the state, we would have drones that would automatically, once an hour, on the hour, take off, go up about 3,000, 4,000, 5,000 feet, maybe higher in some situations, and come back down, automatically sensing the upper atmosphere. Doing that at even just 5 or 6 stations would make Illinois the most densely observed upper atmosphere state in the country. So it really provides a revolutionary idea and look at the upper atmosphere, which again is super important for forecasting how strong a storm is going to be, the tornado potential of that storm, how much water is in the atmosphere to precipitate out. So when we get heavy precipitation, like what we experienced last year in Rockford, better forecasts of those kinds of things. So this is a really exciting push from, there's a collaboration between the University of Illinois Prairie Research Institute, which is I'm part of, as well as the Department of Climate, Meteorology, and Atmospheric Sciences. We have a ton of partners all over the state, including Extension. It's been a great partner. And our current mesonet has several sites on Extension land, including at Freeport. It's, well, I guess that's community college, but there in Monmouth is one of our sites for research farms. So the plan is we right now are working and have worked to propose a federal funding, federal earmark for the mesonet to build out and to test the drone systems over the next year or so. And then we're at the same time putting together a coalition of folks to support growing the mesonet to that 100 stations, like what we'd ultimately like to get to. So it's the ground floor that we're starting at right now. But I think that what we've seen, not just at the university, but across the state with partners in state agencies, private industry, the National Weather Service, and others, that I think there's a lot of momentum for this and there's a lot of need for this. And I mean, this year, right, 2026 has shown us 173 tornadoes, that this is something that's really important. So yeah.
Yeah, that sounds like a great proposal and something that'll have really awesome implications for not only what you do, but what a lot of people are doing. So that hopefully comes to fruition in the near future. And I know you mentioned more of like a local, almost like a citizen science thing, right? I think you briefly mentioned it in your description. That's CocoRa's, right? I wanted to give you a chance to talk about that too, in case anyone listening would be interested in participating in that.
Yeah, so I mentioned the National Weather Service runs these weather stations that are collecting precipitation, but they're really sparse. And we know, I mean, right, anybody who's experienced summertime precipitation in Illinois knows that one part of a county could get a bunch of rain and the other part of the county is completely dry. So one of the systems that's really helped fill in the gaps in rainfall monitoring is CocoRa's, a citizen science initiative. Hundreds of people across the state of Illinois, and it's nationwide, but here in Illinois, hundreds of people have the same rain gauge. It's a manual rain gauge. It's $35 online, but it guarantees more accurate than anything you get for free at the seed or chemical show. And what it is folks put up that rain gauge. They go out once a day, right around 7 a.m. usually, record how much rain they received, especially if it's zero. That's really important for drought. And then they put it in either on an app or online. And then what you can do is you can go see everybody's measurements. And so within a certain county, you may have a few dozen people measuring, which really helps fill in the gaps, like I mentioned, between the National Weather Service observations. So if folks are interested in monitoring weather, if they're already measuring rain, definitely encourage folks to look at the CocoRa's system. It's really easy to sign up. Like I said, it's $35 for the rain gauge, and which is totally worth it. As a gardener, I would say that if you're using the nearest National Weather Service station as your source of information for how much rain you got in your garden, it's not accurate at all. The rain at the National Weather Service is accurate, but it's not representing necessarily what you got. Just quick story that last year was a very dry year in Champaign. My in-laws live about 10 miles from us as the crow flies. And in that short distance, they got 5 inches less rainfall than we did. So it could be a huge 5 inches. So there could be a huge difference even over a relatively short span. So yeah, like I said, definitely encourage folks to check out the CocoRa's webpage, and you'll reach out to me if you have questions or are interested in joining.
Perfect. Well, Trent, thank you so much for having this conversation with me today and taking the time to share your expertise and, talk about some of this really important stuff that I think many folks are going to be interested in hearing about. Yeah.
Thanks, Kathryn, for giving me the opportunity. It's great talking with you.
Once again, that was Trent Ford, the Illinois State Climatologist with the Illinois State Water Survey. Be sure to join me for the next episode of Talking Crop, for which I'll be speaking with Madeline Solovsky, Michigan State University Extension Conservation Agronomist Educator. That episode will release on July 22nd. Until then, thanks for Talking Crop.